Hello everyone and welcome to my channel. Today we will be discussing a fundamental concept in the data structure and algorithm, the queue. Queue are an essential part of the programming and computer science, helping managing data in a very organized way. Let us dive right in and explore how queue works, their types and real-world applications. Introduction to queue. So what is exactly is a queue? In the simplest term, a queue is a linear data structure that follows the FIFO principle, first in, first out. This means that the first element added to the queue is the first one to be removed, just like a line of a people waiting for service. The first person in the line is the first one to be served, and other one in order. A queue has two main ends. One end where elements are added called the rear, and the other end where elements are removed called the front. This setup emphasizes the FIFO order, where items enter from the rear and exit from the front. Basics operation of queue. Let us go over some basic operation associated with queue. Enqueue. This operation is used to insert an element into the queue. New elements are always added to the rear of the queue. Dequeue. This operation removes an element from the queue. Elements are removed from the front, maintaining the FIFO order. Peek or front. This operation allows us to view the first element in the queue without actually removing it, which helps us understand the current status of the queue. Is full and is empty. These conditions check if the queue is empty or full. These checks are essentially useful in managing queue size and ensuring we don't exceed these limits. Now we know that the basics operation. Let us discuss different types of queue. Linear queue. This is a standard queue where elements are added at the rear and removed from the front, following a straightforward FIFO approach. However, it has a drawback. When elements are dequeued, they leave gaps, and the queue eventually fills up, even if there is a free space in the beginning. Priority queue. A priority queue removes elements based on priority, rather than the order they are added. This is particularly useful when some tasks or items needed to be proceed before others, even if they arrive later. For instance, in an emergency room, critical patients are treated first, regardless of when they are arrived. Circular queue. In a circular queue, the last element is connected back to the first element, forming a circle. This setup solves the limitation of the linear queue by efficiently utilizing available space, as the rear can wrap around to the front when necessary. Applications of queue. Queues are widely used in various real-world applications. Here are a few notable ones. Print spooling. When multiple documents are sent to a printer, they are queued in order they were submitted. This ensures that printing occurs in a controlled and organized manner. Call center systems. Calls are managed using a queue, so that the first call received is the first to be answered. This method is essential for customer service and ensuring fair handling of calls. Web server request management. Web servers use queue to manage incoming requests. When multiple requests hits a server, they are proceed in the order they were received, preventing the system from being overwhelmed. Task scheduling. Many operating systems uses queue to manage task scheduling, where tasks are executed based on their arrival order or priority level, ensuring efficient CPU utilization. And to wrap up our introduction to queue in data structure and algorithm, we have covered the basic concepts of queue, how it works with FIFO principle, explored different types of like linear, circular and priority queue, and looked at real-world applications that shows up how essential queue and technologies are. Thank you for watching. See you next time.